Welcome to the session of fluid mechanics tutorial. This session I'm going to talk about the hydrostatic forces on submerged plane surfaces. Now, before I begin, let me pull up this diagram here. Okay, this is actually a diagram of a dam. And you can see here that okay, this is the wall for the dam, and this homogeneous fluid that is inside this this particular dam, and in the arrows in magenta is basically the pressure variation. It starts from 0 gauge here and work all the way down through GH. Now, in hydrostatic problem, you probably have the atmospheric pressure acting on both sides of this wall. So you have atmospheric pressure here, caused by this rectangle here, and you also have the same atmospheric pressure that's acting on the other side of the wall. So what you can do is you can subtract the atmospheric pressure, and this will be your so-called diagram for submerged hydrostatic forces problem. What I have here is a plate. I'm going too fast here. This is actually the plate. Now the plate is being submerged inside this liquid here, and the depth is H, and you have pressure acting normal to the plate, and the resultant force, which is the force acting on this plate, is going to be at the centroid of this plate here, and it's been taken as the resultant force is actually the average pressure times the area of the plate. And you can take the average pressure. This is the average pressure, root GH, and P0, P naught is actually the pressure here. Now, since P naught also acts from the bottom of the plate and around it, so you can basically take out the P naught for gauge pressure. So your resultant force can be reduced to that's the pressure acting at the centroid, which is also the average pressure in this particular case, and that is equals to rho GH times the area of the plate, which is A times B. Similarly, for a plate that is being hanged vertical to the surface of the fluid, you will have the pressure variation, and this is actually the resultant force. And as you can see, the resultant force is not acting in the centroid. The centroid is probably somewhere here. The reason being is because you have the pressure also coming from this depth S. So your resultant force will be your P naught plus, this is the rho GH portion of it, and this is the area of the plate. So let me put up another example so you can see this thing better. Okay, now here's just the question that's being asked. Let me get it in place here so at least you can see it better. Okay, now consider a 4-meter long and 4-meter wide and 1.5 meter high above ground swimming pool. This is a swimming pool. It's filled with water. So the blue color here is actually water to the rim, and this is the rim. We are asked to determine the hydrostatic force on each wall, is the wall here, and the distance of the line of action for this force from the ground. And this is the ground. This is ground. Let's forget about part B for a moment. Just do part A. What is the hydrostatic force on the wall? And the distance of action of this particular resultant force. Okay, let's do this. Okay, now. Okay, from the previous lecture, your resultant force is the average pressure times the area for the plate. Now we already know the area, which is I think it's given here for the area is 4 by 4, the length and also the width. So now let's find what is the average pressure. So the average pressure is given as rho G H, and in this particular case, that's the rho of water from the swimming pool times G times H, and H here is actually acting on the centroid because that's the average pressure that we're looking for, and that is going to be H over 2. So plugging in, you have 1000 kilogram per cubic meter times 9.81 meters per second square, and H is 1.5 over 2, and that's 0.75 meters. And that will give your P average at 7375 Newton per meter square, or Pascal. Therefore, your resultant force is the average pressure times the area. So you have your resultant force 7375 Pascal times the area, which is given as 4 meters times 1.5 meters. And that gives you 44.145 Newton, or 44.1 kilonewton. Okay, so that will be it for this session. I will come back again and show you the tutorial on submersible plate for vertical with different configuration, and also for incline plate. Thank you. Thanks.